It's not even so bright. Let me see how this one come out. It looks a bit more distant, to be honest. Okay. Okay, I think I need to have this in my hand, because this idea of keeping it standing here is not good. I think with this I can get a good perspective on everything. Hold it with your left hand and right with your right. Okay. Okay, let's start then. There's no need wasting more time. Okay, let me try and be I got my wife doing this now. Let me see, can I go backwards? Okay, already as far back as you can go. First of all, I have to stay here for now. Being on this side. It's better on this side. I can't see the motherboard properly, so anything will just work. I've just given myself so far. Okay, if I can just get it to be a bit more towards this side. Yep, perfect. Okay. Hello everyone. I have my new, hello everyone. It's about time I drop my 2 cents on why you water cool your system, how to water cool your system, how to optimize your water cooling loop. Basically, I'm a mechanical engineer by background, so I guess I've been dribbling and dabbling into water cooling for the past about 8 years now, and I basically get some of my theories from YouTube and look at how other people do their systems. So I learned how to bend acrylic on YouTube, to be honest. So I've taken a lot of information from YouTube, and I believe it's time I give something back if it's useful to some people, I guess, because I'm sure I'll get a lot of headache for this. Well, I guess I'll just throw my 2 cents in, see how it goes, you know. I guess I prefer if some people give me some constructive criticisms against my theories, because as engineers, I guess one thing we don't do much is to put your ideas out there and see how people take them, what directions, you know, what perspectives you can get from others, you know, to help improve your own system. Well, that said, this is my Haswell E build. My previous build, if you look on my channel, I previously had an two 500K, 2500K Sandy Bridge build, sorry. That was 2500K with, I had this card also in that build, but it's not on YouTube at that time. But this is 780 GTX water cooled. That was done with flexible pipe, 3/8 by half-inch flexible pipe work, and it was okay, performed well. I moved some of the parts from that build to this build because I scrapped that. I don't have a need for two computers, but there we are. I'll just give you a walk around on this build, and now further explain how I displayed everything and why, the reasons why everything is set up in the way, the layout we have here. First of all, the processor is a 5820K. That's the Haswell E, the lowest spec on the Haswell E. It's a 6-core, 28 PCI lanes. I think it's 3.3 and turbo is 3.6 gigahertz. The water block on that is an Alpha Cool H17 Yellowstone. It's a copper water block. I'll explain a bit on that later on. The GPU obviously is 780 GTX with EK water block also on that. I've got G-Skill rip jaws, 24 megahertz, 2400 megahertz RAM. That's 2400 megahertz RAM. The motherboard is an Asus X99-S. This is not the deluxe. This is the -S, -XS, because I thought I didn't need all the other components. I would like to buy one or two other parts that come in the deluxe, possibly the Wi-Fi. That should be what I would need. The rest I don't need. What else? What do we have here? I have a 280 rad. Then on push and pull configuration, the two 140 fans that came with the casing, because it's a 760T, you should see that by now. The two 140 fans that came on the inside, and this other two, these are all Bitfinex 1800 RPM fans. I have five of them in total here. That's two here, two on this rad, and one on the theme of the build was supposed to be a white and black configuration, but I guess the black is just a bit too much on this. I would like to, maybe later on when I put my next 780 GTX, I'll have a white acrylic plate at the back to try and attenuate the whole look of the case and bring out, but we'll see how that gets along, because that's my next plan to finalize this build. But regardless, I have further on, I got a 140 rad. Both radiators are 60 mil thick. They're not the thickest out there, but they're quite thick, to be honest, and it's a reason for that I'll explain later on. Also, they both have push and pull configuration, and I know there's a lot of arguments on the net over which way it's better, push, pull. I use push and pull, and I'll explain why later on. Just bear with me for now, I guess. The pump is an EKDCP 4.0 pump. I will explain exactly why I chose this pump. This pump was in my previous build, and it has been with me for like 2.5 years, 3 years now. It's a perfect pump for what I need. As an engineer, engineers optimize equipment. We don't, you shouldn't be so wasteful. Your design should focus on your requirements. That's what optimization is all about. So I'll explain more on all that later on, because this video is supposed to cover a lot about water cooling and what you need to do, which way would give you the best advantage. To go into a lot of detail into what's the reasoning behind a lot of the things that are done in water cooling, which I have not seen on YouTube. I haven't seen videos on explaining to you the heat capacity, for instance, the heat conductivity of the fluid of water, the radiators, and what you gain from an engineering perspective on push and pull configurations, turbulence for the CPU block, laminar flow for the, I'll explain all of that later on. Well, next is the water cooling loop. The way I set it up for now is obviously this is the reservoir. It goes down into the pump. the pump, out from the pump into the GPU, through the GPU to the CPU, from the CPU I have a temperature probe here, and there's another one just before it goes into the pump, so I can judge the efficiency of the cooling system based on the inlet temperature and the outlet temperature of the liquid coming out of the system. So from the CPU block it goes into the first 280 rad. That's the reason why it goes here. I could have used this, but I decided to use that. I'll explain all that later. And then it goes down to the 140 rad and back into the reservoir. Let me take this camera closer, just show you some of the other parts of this build. If this camera will let me. Okay, there we are. So if I go a bit closer, that's the EKDCP 4.0 pump. The PSU is a Silverstone Strider 750 watt gold. There's a reason why it's in this format. Normally you have your PSU facing the other way around, sucking in air from the bottom, and there's a reason why I put it this way. Obviously the 760T case comes with a what's it called, a mesh at the bottom, so that wasn't the reason why I used this. There's another reason later on which I will explain. Further on you can see some of the 140 fans are off. That's basically because of I'm using the fan expert on the motherboard, the Asus X99 fan expert fan controller. It allows you to switch up some fans if you don't need them. Like I said, this system is all about optimization of the cooling system, so if you can save energy when you don't need it, then you switch it off. But let me go into the reasons why these fans are running right now. For now, while I'm just normally web browsing or whatever, I have these two fans running. Now the two fans on the inlet, I have them running also, but they are still controlled by the Asus Expert, but that is done under PWM control, which allows me to drop the RPMs to very low speeds, and that gives me about, let's say, I think out of 1200 speed on the fans, I get about 400 RPM on both of the inlet fans, saving some current, I guess. But these two fans are on this 140 rad. They are plugged into the motherboard, the case's fan control, and the case fan control has two settings. So why I did that was I didn't want to trust the fan expert software control only. Obviously it will take a lot. There are other safety systems put in place by Intel and Asus. If the temperature gets too high, the CPU will cut out and switch up the system. The motherboard also, the chipset and all that, they will all shut down and take off the system if I don't have temperature control or if none of the fans are running. But I wanted to have two fans running just in case anything goes wrong with the software of the fan expert and it stops the fans or throttles them or does whatever. This would still be running because this is like a hardware control. It's supposed to give me the ability to ensure that I have cooling on the system, some sort of cooling, not the full system cooling, but some sort of cooling just to save the computer. That's the idea behind that. Knowing that the the fan control that comes with the casing is simple and basic. It doesn't have software or no, it is just simple fan control. The pump is also controlled through the case control because I would have done that through the motherboard, but I decided not to because the pump when you're running a cooling system, you need to use how do I explain this? You need to use a fixed. You need to try and fix your pump performance. It's quite important. Instead of having variability in the pumps, you rather have variability in the fans, and that is because of a couple of that's because of the fact that the flow rate and pressure is governed by the RPM of the pump. Now if you play around with the RPM, the pressure nosedives, the flow rate also nosedives, and then you won't get turbulent flow. You might not get turbulent flow, and it's important to get turbulent flow in some areas of this cooling system, and I will explain later. That will give you more heat extraction capability from the water blocks, and possibly more heat deposition on the radiator. So I prefer to have the pump run at a specific speed which gives me the least pressure loss on the system. So that speed is fixed by the two-speed nature of the case, but from testing I did, the speed I got on the pump after when I tested the pump while running just off the case's minimum setting was perfectly okay for what I need. So I'm not changing that. I can ramp up the pump, but that doesn't give me any benefit, just waste power, and obviously the life of the pump is affected. So that's like an overview of the system. I have a TV card here, but that's nothing. I've got 2 hard drives. There's one on the roof. I hung that on the roof specially. And I have an SSD, 256 gigabyte SSD down there. Samsung 840 Pro is my old SSD. So that's about that for my system. I would explain in my next video exactly what is going on here and why this is put up this way. But if you can take a mental picture of the system now, because I have to use some websites and stuff, information I just saved up on the computer. So again, the loop is straight from the reservoir into the pump, obviously through the temperature probe, into the pump to the GPU to the CPU to the 280 rad, 280 rad to the 140 rad back in to the. I intend to SLI this system, so I'm going to get around a 780 GTX and water coat and still maintain these rads. I'll explain later. I'm sure most people would think it's not optimized properly, you need more radiators. No, you don't. If you properly plan your system and do necessary calculations if you want to, because most of these things are over engineered at this point, but I'll explain later. Alright, see you in the next video. Bye. Hope this picked itself out well. There's some more. Okay.